This is CCEA A2 Pure Maths. We're generally looking at integration here, which you can see in the question. However, there's a bit of partial fractions thrown in there as well. And this is a past paper question. It's from C4 January 2011. And this then is question 1. So part AI then is to solve this in terms of partial fractions. So it's going to be 1 over x plus 1 upon x minus 1. So we would set that up as a over x plus 1 plus b over x minus 1. That's the same then as a upon x minus 1 plus b upon x plus 1 all over x plus 1 x minus 1. And we can equate then the two top lines. So 1 equals this bit here. So we have 1 equals a upon x minus 1 plus b upon x plus 1. If we let x equals 1, that means 1, that disappears, and we get 2b. That means that b is a half. If I let x equal minus 1, I get that disappears, and I get 1 is minus 2a, and that gives me the a then is minus a half. So write that in partial fractions. That means 1 over x plus 1 x minus 1 is equal to, let's actually flip these the other way around. Because my b was positive, I'm going to write then 1 over 2 x minus 1 minus 1 over 2x plus 1. Hope you're okay with that. We move there. Part 2 then is to integrate that. So the integral, this question here, hence integrate this. A couple of different ways really of writing this, but let's go for 1 over x plus 1 upon x minus 1 dx. Because there's a half on both of those there, I'm actually going to take out the half. So it's going to be a half upon the integral of 1 over x minus 1 minus 1 over x plus 1 dx. And that equals a half upon ln x minus 1 minus ln x plus 1 plus c. You could join those together using the laws of logs if you wish, that would be fine. You could multiply your bracket out, that would be fine as well, but any of those are good. Let's go on then to part B. It says use integration by parts to integrate x cos x. It's about as basic as it comes really for an integration by parts question, so hopefully we're okay with that. Integral of x cos x dx. I'm going to let u equal x. I'm letting dv by dx equal cos x. du by dx is 1, and v integrating cos, of course, gives me sin x. Now, fill in my blanks, so it's uv, so it's x times sin x, minus the integral of v du by dx, so it's sin x times 1. That means I get x sin x. If I integrate sine, I get minus cos, so that gives me minus minus cos plus cos x, and don't forget your plus c.